Okay,
I
and
don't even have that one.
we'll be doing section 13-4A, problem number 7. And I'm going to set this up in GeoGebra to make my drawing a little cleaner. So I want the base of my right pyramid to be a regular hexagon. So under more, I'm going to choose regular polygon. And hexagon would have 6 sides, so I'll tap 600. No, I'll just tell it. I want to have 6 vertices. So there's the base of my right pyramid. And for purposes of drawing this, I'm going to put on a point up here so that I can connect sides to that. And right now, I'm not using GeoGebra as a construction tool. I'm just using it as an advanced drawing tool to help my drawing be clear. For making the regular hexagon, it was a construction. Okay, so we have a right pyramid. So a right pyramid just means that the altitude coming down from this point here would have to be at a right angle with the base. So there's a right pyramid. This one would not be. This one's oblique. If it's straight up and down, where your altitude would come down straight down through that apex and hit in the middle of your hexagon. So I'm just drawing in my altitude here with a dashed line. If that comes down and hits here at a right angle, then you have a right here. All right, the sides of this hexagon have length 12. And it's a regular hexagon, so all the sides are 12 on the base of that. And the altitude is 9. Find the total surface area of this pyramid. So in other words, we're going to have to find the surface area of this hexagon. And then we also want to find the areas of all of these triangles, these 6 triangles that make up the faces of our pyramid. So we've got 6 of these triangles where their base is 12. And we've got this hexagonal base that we have to find the area of. Okay, so now I'm turning back to page 860. The surface area of a right regular pyramid is given by surface area equals 1/2 times the perimeter of that base times the slant height plus we need the area of our base. The area of the hexagonal base. Okay, and the reason that we have a half times the perimeter times the slant height is that each one of these triangles, we're doing this our regular triangle area formula. What is that? How do you find the area of any triangle?
Sorry, half base times height?
Half times base times height. So we have half times base times height in the first triangle, half times base times height in the second triangle, half times base times height in the third triangle, half times base times on all of those triangles. Well, and then you add them all up, right? Well, in the end, the base in every one of them is 12. So it turns out that you're really taking the perimeter. So that's why you can just put in the perimeter and boom, it's giving you the areas of all of those faces at once. And then we need the area of the base. Okay, so let's do the triangle part first. We need that slant height.
I figured out where I went wrong.
Where did you go wrong?
I put 12 as the slant height.
No, the 12 is the height of
The hexagon, the side of the hexagon, and which makes sense. I don't know. Okay, I don't know. But I want to see this.
okay. And so we know that that is 9. And so now we just need to figure out our slant height. So what are your thoughts on finding that slant height?
Diana, I mean, I when I did it the wrong way,
When I tell you that I went blank on this problem, no matter how I approached it,
see, like, I mean, I did it all, but I mean, what I did was I ended up, I put 12 squared equals 9 squared plus s squared, when I think actually, shouldn't it be 12 squared plus 9 squared equals s squared, which is the slant height? Would you use the Pythagorean theorem on that?
It's the Pythagorean theorem, but I don't think it's 12.
Oh, no, never mind. Nope, I'm sorry. That's
This point.
putting it in wrong. Wait, so 9 is the height, and then
Yeah, 9 is the
oh,
height of
no.
the leg of that right triangle. The slant height will be the hypotenuse. That's what we have to solve for. But what's going to be that other leg?
Wait, hold on. What about the perimeter? Wait. Wait, but hold on.
I even tried looking up some resources for this and I found something called the apothem. Does that have anything to do with it? Like, I'm genuinely really lost.
Yes. When you're finding the area of that hexagon, that will come into play. But right now, we're just finding what the slant height is, so we can plug it in here and get the areas of all of the faces.
Does it have anything to do with the Pythagorean theorem?
Yes. So in order to find that slant height right there,
Mm-hmm.
Pythagorean theorem, but Aaron, where you went wrong is that this base of this triangle is not
It's not 12. Well, it's half of 12.
half of.
I did half of 12 times perimeter. And then I added, what was that? The base, I think, or something like that.
You have half. Um,
I don't know. I did half of.
well, first we have to find, first we got to find that slant height. So we can
Okay.
use Pythagorean theorem now.
Okay.
Have
So
nine-
we know that the height is 9, and then half of it is 6. And so we're trying to find that hypotenuse. So 9 squared plus 6 squared equals x squared.
There's
Or, yeah, squared. 81 plus 36. 117 equals x squared. So the square root of 117.
I am getting root 117.
Yeah, that's what I got. Square root of 117. Okay.
Perimeter would be 12 times 6.
Oh yeah, because each side is 12 and there's 6 to the hexagon. Oh, I got that part right.
We're just gonna do 117.
So half perimeter side plus the base.
We need the area of the building.
Perimeter times length plus base.
So we're finding the area of, I want to find the area of the base of this hexagon. I'm just gonna look at one of the triangles and we'll take it times 6. Now the base is 12. I don't know. But
That line you just drew down the middle of that triangle, is that what that apothem is?
but I do know I have 6 right here on the hypotenuse.
Mm-hmm.
Wait a minute. I made a mistake, Aaron. I think you were right. I think that this right here, I wrote 6. That is the same length as this side right here.
Oh.
And I just realized that when I went say this one.
Okay.
I think I was out of my mind. But that's me. Half of this is 6. And then we have to find the bottom. Right here. Plus b squared.
Equals 12.
I'll go back and fix that one once we get this one done. Okay. Well, squared is 144. 6 squared is 36. 144 minus 36. Who has that?
108.
And then we can take the square root of these sides, ignoring the negative because we have a length. The square root of 108. So now we have to think, is there any perfect square factors of 108?
Four probably, I would.
Not being divided by 4. Seven. So that shows me that there's
And there's nine.
well, what about 36? 108 divided by 36. Can you do that?
3.
Oh, that's 13 times 30. Wait, hold on.
Because I know 27 is 3 times 3 times 3. Yes, okay. So we can break 108 into 36 times 3, root 36. So root 108 we can write as root 36 times root 3. And the square root of 36 is 6. So we have 6 root 6. You follow me? Okay, but that is our apothem. Here. So now that we have the apothem A, we can put the area of this little triangle. We have a half times the base. Well, height, which is 6 root 3. The area of one of these little triangles, but how many of those triangles are there?
6.
There's 6 of those in that hexagon. So we'll take that times 6.
Mm-hmm.
So first of all, a half times 12 is 6. So
6.
we have 36 root 3 is this area, but we're going to have to take that whole thing times 6. So that 16. Take the 15.
I'm sorry, I'm not following on this part right here. So I know half of 12 is 6, but then what do you do with that 6 square root 3?
6 times 6 is 36. So we have 36 root 3 is the area of
Okay.
but we got 6 of those little triangles. So we take 36 root 3 times 6, giving us a base area of 216 root 3.
216 root 3.
Okay, now let's go back and fix this mistake over here. Instead of 9 squared plus 6 squared equals L squared, it should have been what Aaron was telling you. What do you think? It's from the center to this vertex B. Like 12 because we have a regular hexagon. So it should be 81 plus 144. Then we have 81 plus 144. Is it 165?
Is what 165?
81, wait, no, that would be right. 81 144 would be
225,
how much?
225.
25. And the square root of 225 is 15. So now we take that L and we're going to put it in here.
I'm so confused.
She's gonna have 13 just like this on the test.
Still, we're still not getting what it is.
Hold on, so you got your perimeter as what? What did you get the perimeter for your base?
72.
But didn't you get that? Oh, I got my sides messed up again, sorry.
I am thinking that we drew this triangle. I still don't think it's 12. I think that it's the apothem. If I look at a side version of this triangle that comes down from the vertex, and then the base of it is A. And then we have the slant height. I think we've got 6 right there. Instead of drawing this to vertex B, I think it should have been drawn as an apothem to that triangle right there.
So you get that right angle? So then would you find the area of those 12 triangles instead of 6 triangles and then get your area that way?
Still have 6 triangles. You still use that formula at the
Oh, I
bottom.
thought you were taking that one triangle, so like from BHC, that triangle, and splitting it to 2 right angle triangles.
I'm talking about, instead of going from BHG, that triangle where we
Okay.
have 12,
Okay.
I think that it should have been going to this point in the center of CD. Or better yet, look at it as this very front. Look at it just at the front where
Okay.
we have
Sure.
coming down through the apex is 9. And then coming towards you is this apothem of 6√3, and then the slant height that we don't know. And this is a side view of that triangle. So if I do the Pythagorean theorem on this one, 9 squared plus 6√3 squared equals L squared. What will that give us? So here we'll have 81. This will be 36 times 3. $108. Add 108 and 81. is 189. Equals L squared. And if we take the square root of both sides, is there any perfect square that we can pull out of 189? Is there any perfect square factors of 189?
Oh.
9. We can rewrite that as, so the square root of 189, we can rewrite that. Root 9 times square root of 189 divided by 9 is 20. Minus 3, so we've got 3 root 21. And that is our L. Right. Down here in our formula. 3 root 21. And now we can take that times 72 times a half. So 72 divided by 2 is 36 times 3 is 100. Now, no 8 plus area of the base, which we figured out somewhere else, 216 root.
2/16.
Or root 3.
Yeah. We got it. Now, I have a feeling that there's a formula out there for finding the area of that regular hexagon. Instead of doing it piece by piece as we did.
I found one, but
Wait, I thought I had it base time height divided by 2.
Well, that's to find the area of
No,
this triangular piece here that I'm coloring in. We did that and we took it times 6. But was it Diana? Did you have
I think I did. Hold on, let me
a
see.
formula for the entire area of the hexagon without doing it piece by piece?
So I did, no, not the entire 3D shape. So I found the area formula for the hexagon base and then the one for the triangle. And I think that's where I went wrong.
Okay, what formula did you find for the hexagonal base?
Half of, hold on, half of apothem times perimeter.
Half the apothem times the perimeter. Okay, let's do that. So if we had half of the apothem times the perimeter, it would have been half of root 3. Times what?
Times 72.
So that would have been
The perimeter, isn't the perimeter 72?
oh yeah, 72. I act like I stayed up all last night. I almost did. Got home. My flight landed around 10:03 this morning.
Oh, wow.
Oh my gosh.
We have um
Yeah, that's
times
that's-
6. There's your 108.
Wait, how did you get 108 from that?
So
Yeah.
16.
well, no, that's gonna be your
That's
216.
maybe your 216. So the area of the base that we found right here, we found it by
Oh, I see where you
found
are.
it by finding the area of just one of the triangles and taking it times 6. But you could have used that little formula right there that she
A
just
formula. Wow.
half
I had the right formula, just had the wrong
times the perimeter.
apothem. I did the apothem
Oh,
for 12.
So that gives you the area of the regular polygon.
Yeah,
So
that's what I
you
found.
use that formula. So looking back at which chapter would have given us, well, it would have been the measurements chapter. Areas of polygons and circles. So that would have been in section 13.2. Area of a regular polygon is on page 828.
Area of a regular polygon,
A half
828. Yes. Half apothem perimeter. Yes.
So that would have shortened what we did by a step.
But that would have only been the base.
That would
Right.
have been the area of the base, yes.
oh, look at that. Huh. Oh, yeah, and then it explains to, okay.
So we could have rewritten this surface area formula a little more descriptively if we had I'm just going to put it on the other side of it. Okay, so the half times the perimeter times the slant height gave us the areas of all of the triangular faces. And then for the area of the base, we could have used a half of the apothem times the perimeter. But the key to both of these, even the key to finding the slant height, was the apothem. We needed that apothem right here in order to find the L, the slant height on this right triangle where we have the height was 9. The slant height we didn't know, and it's coming down here through the center of this face on the right, hitting there at the center. And then here we have the apothem. But it's a little easier to see a side view of it, which is what I do here.
Yeah, I'm while we were doing this, I had my GeoGebra pulled up on my other screen, and it really is kind of cool to be able to see it and play with it that way versus my
Now,
really bad
I'll
drawing.
bet you money. So now that you have this answer, I bet you money that there's a pre-made
Oh,
GeoGebra right hexagonal prism. Let's see if we can find it.
let's see who can find it.
But before I give up on the one I drew, let's just clean this up a little bit. The key to this whole thing was finding that apothem right there. And we did it by knowing that this side was 12. Therefore, the base of this little guy here is 6. And we know this is 12. So using the Pythagorean theorem, that gave us our apothem. And then once we had that apothem, we could do this side view triangle. There's the apothem. We had the height of 9. And then this lateral or this slant height L came up through the center of that triangle, that triangular face. So there's our triangle. Here's a side view of it. where we have the apothem, the slant height that we had to calculate using the Pythagorean theorem. So first we had to find the apothem, and then find the slant height, then you could put everything into that huge surface area formula, other right. Here. No, let's erase all this. Let's open and search for surface area. Hexagonal. Here. That's pretty detailed. No searches.
I got no, yeah, I got nothing either, but I did get a regular hexagon.
How about a right hexagonal pyramid? Nope. You did find a regular hexagon?
I did, but
Would there be a difference between like a hexagonal pyramid versus a right hexagonal pyramid?
Yeah, there would be. If it wasn't a right hexagonal pyramid, you don't have right triangles to work with, because the line coming down, the height coming down through the apex of your pyramid wouldn't have hit the hexagonal base at a 90-degree angle.
Got it.
Here's one that shows a pyramid exploded, showing all of the surfaces where you're finding a surface area. So I know that it's only a square base, but this can help us see that that slant height that we were looking for. You can draw it a little better here. That was the L. And then here's the height. So there's the height. Here's the slant height coming down. And right there, in our picture, that was the apothem. Does that help?
Yes, that makes a lot of sense. It was that slant height and the apothem that I didn't calculate properly. Thank you for that.
Yeah.
yeah,
I probably had nightmares with that problem.
and you know, this is when I went back to like 3 or 4 different times and I got a little more clarity, but what I never did change was that 12 went around the base of the hexagon and not the slant height. But I mean, I got lots of practice out of it. But yeah, so Diana, thank you for bringing that.
So I would highly recommend that on your note card for when you take the test, that you have that surface area formula written down. Because that is not one that you're going to use in your everyday life. I'm not requiring you have it memorized. But you do want to have it on your note card in case that this problem is on the exam. And if this problem is on the exam, I would recommend that you save it for the very last one that you do, because it's quite time consuming.
Yeah, it's very it has a lot of layers to it.
Mm-hmm. This is one that will separate the A's from the B's on the test.
Yes, the cream will rise to the top on that one.
Maybe A's from I was a total F on this one.
Yeah, it was challenging. Like I kept getting 63, wait, 43 plus 18 square root 7. And I'm like, how do they get that? Anyways, so yeah, it all makes, it all makes more sense now. And at least seeing where I went wrong on it.
Let me stop recording on that problem.